Case 2, when two forces are acting on a body in the opposite directions. How do we find the resultant? When they're acting in opposite direction like this, meaning they can tell you the angle between the two forces is 180 degrees. They are saying the same thing. Please take note of that. When two forces are acting on about an angle 180 degrees to each other, even they're acting in opposite direction. So call this F1, call this F2. To calculate the resultant, you say resultant is equals to F2 minus F1, meaning provided F2 greater than F1. But if F1 greater than F2, it will be F1 minus F2. So it will now be in the direction of F2, in the direction of F2. Because F2, the body will move towards the direction of F2 is bigger than F1. So this is what we are going to use to find the resultant, F2 minus F1. So for example, e.g., and it must be noted that a minimum force, when two forces are acting on a body, the minimum force obtained is when the angle between the two forces is 180 degrees. So the minimum resultant force is obtained. The minimum resultant force is obtained when the angle is between the two bodies is 180 degrees. Please take note of that. So let's see example 1. Example 1. Two forces of magnitude 3 Newton and 4 Newton act on a body of mass 10 kilogram, in opposite direction, or at an angle 180 degrees. Calculate the A. Find the resultant force. That is 1. B. Find the acceleration of the body. C. Find the velocity of the body at t equals 3 seconds. D. And the distance covered. And the distance covered in 10 seconds. Find the work done in the part of the question. So let's see A. Resultant force is equal to, why they are acting in opposite direction, it will be F2 minus F1. So it will be 4 minus 3. So it will be 1 Newton in the direction of 4 Newton, because it's bigger than the 3 Newton. So that is the answer. The answer is 1 Newton. B. Calculate the acceleration. Resultant is equals to mass times acceleration. This one is 1. Acceleration is given to be, mass is given to be 10 times A. A is equals to 1 divided by 10. So we have 0.1 meter per second squared. So C. We have to calculate velocity of the body at t 3 seconds. The body was assumed to be initially at rest, so 0 meter per second. So we have to find final velocity, we don't know. And time is equals to 3 seconds. We have known our acceleration to be 0.1 meter per second squared. So for that reason, we are going to use V is equals to U plus AT. So it's equals to V, U is 0, A is 0.1 times 3. So the answer is 0.3 meter per seconds. D. Distance covered in 10 seconds. S is equals to UT plus half AT squared. Initial velocity is 0. Time is given to be 10 plus half A. Acceleration is 0.1 times time. This time they said in 10 seconds. So 10 seconds. So this one is 0 gone. This one will be 10, 5. So the answer will be 5 meters. The answer will be 5 meters. So E. Calculate the work done as indicated in D. So work done is equal to force times distance S. So force, that's resultant. Always make use of your resultant. Resultant is 1. That is 1 times distance. Distance in D is 5. So the answer will be 5 Newton meter or 5 joules or 5 Newton meter. 3. When the angle between two forces acting on a body, when the angle between two forces acting on a body is 90 degrees at right angle to each other. So you have this, you have this. This one is F1, this one is F2. So to find the resultant, this is the resultant. He said this is the resultant. So you can trace it down. When you trace it down, then you have it to be F1, opposite side of a rectangle are equal. So see the same thing. So in that case, you can use Pythagoras theorem. Using Pythagoras theorem, we state that the square on the hypotenuse is equal to something on the other two sides. So R square is equals to F1 square plus F2 square. So R9 is equals to square root of F1 square plus F2 square. That is Pythagoras theorem. This we are using Pythagoras theorem. So this is the formula we shall be using to calculate the resultant force when two forces are acting on the body at right angle to each other, at 90 degrees to each other. This is the formula. Then another thing is, what is the angle between the resultant and the F1? The angle between the resultant and F1, call it theta 1. The angle between the resultant and F2, call it theta 2. So theta 1 is the angle between the resultant and F1, while theta 2 is equals to angle between the resultant and angle between the resultant and F2 and F2. So that's the formula. So we can proceed to have example 1. To example 1. Two forces. Two forces of magnitude 3 Newton and 4 Newton act on a body of mass 10 kilogram. Calculate the A, the resultant force. Calculate the resultant force. B, calculate the acceleration given to the body with which the body moves. The body moves. C, calculate the work done in moving the body through a distance of 20 meters. These are some of the questions they do ask students. So A, you know resultant is equals to square root of F1 squared plus F2 squared. So this one will be 3 squared plus 4 squared square root. 3 squared plus 4 squared square root. So this one will be 9 plus 16 square root. This will be square root of 25. And final answer will now be 5 Newton. That's our resultants. B, we have resultant is equals to mass times acceleration. This is 5 is equals to 10A. Mass is A9 is equals to 5 divided by 10. So this one is 0.5 meter per second squared. That is acceleration. So C, calculate the work done when the distance covered is equals to force times distance, 20 meter. So our resultant force here is equals to 5 times 20. So this one will give you 100 Newton meter or joule. So this is example 1. Example 2. We are given a diagram like this. We are given a diagram. This is a body. So this one is given to be 3 Newton. This one is given to be 4 Newton. It's given to be 4 Newton. So the two forces the forces acting on a body of mass 10 kilogram. The forces acting on a body of mass 10 kilogram as shown above. Calculate the resultant force. We call it north here. We call it east. Calculate the resultant force and its direction. That is example. That is example 2. And its direction. So far it is 90 degrees. You can see it clearly on the board. We are going to use Pythagoras theorem to find the resultant. F1 square plus F2 square root. So what is F1? We'll say F1 is 3 Newton. 3 square plus 4 square, square root. This will be 9 plus 16, square root. This is square root of 25. So the answer is 5 Newton. So we have gotten the answer to be 5 Newton. Another thing we are going to do is to calculate the resultant for. Thank God we have gotten what of the direction. You know, like I've told you, when you draw the diagram, F1 here, F2 here, and this is the result. This is the resultant. This is the resultant. This is the direction they are talking about. That is theta. That is theta. So you can say that this is a same thing as F1, and luckily enough, this is 3 Newton. This is 4 Newton. You can say tan theta is equals to opposite. That is 3 all over what? 3 all over 4. So tan theta is equals to 0.75. You can find theta now is equals to arctan of 0.75. So that is theta, 36.87 degrees. So we want to get this. You can get this, or you leave it like that and angle this. But if you want to indicate it in a cardinal point method, so instead of northeast, so we want to introduce northeast. So I will say this is equivalent to northeast. You have to take away this from 90 degrees to give you 53.13 degrees. You must have been taught in bearing. So you have to calculate this angle. If you at all want to leave it in the cardinal point method, way of representing bearing, northeast. So you leave it at the northeast. So the answer is 5 Newton R is equals to 5 Newton in the direction north, 53.13 degree east. This one is east. That's how to leave the answer. Example 3. Two forces of magnitudes P and P Newton and let me say 12 Newton act on a body of mass, act on a body of mass 10 kilogram. If the resultant of the forces, or the two forces, is 13 Newton, calculate the value of P. Find the value of P. Two forces of magnitude and act on a body of mass 10 kg. If the resultant of the forces is 13, calculate the value of P when the two forces are perpendicular to each other. They are perpendicular to each other. So how by saying result is all equals to F square plus 2R square. So result is 13. So it's 10 square, F1 square, let me call it P square, F2 is 12 squared. So 169 is equals to P squared plus 144. So P squared is equals to 169 minus 144. This one will give us 25. P squared. P9 is equals to square root of 25. P9 is equals to 5 Newton. P9 is equals to 5 Newton. That is example 4. Example 5. Example 4 rather. Example 4. The resultant of two forces F1 and F2 perpendicular to each other. The resultant of two forces F1 and F2 perpendicular to each other makes an angle of 30 degrees with F1 if the magnitude of F1 is 6 Newton, calculate the resultant force the value of F2. The second question. That's the fourth. We want to start by saying you are given a force, two forces, they are perpendicular, F1, F2. Perpendicular, this is the resultant. And the angle here is given to be 30 degrees. And this one is F1, that is 6 Newton. If the angle here, okay, angle between F1 and the resultant, this is the angle given to be 30 degrees. Angle between F1 and the resultant is given to be 30 degrees. So here we have to find the resultant. So we can say adjacent over hypotenuse. So we say cos 30 degrees, adjacent is F1 all over R. So cos 30 degrees is equals to F1, that is 6 all over R. The cross multiply R cos 30 degrees is equals to 6. So R is equals to 6 divided by cos 30 degrees. R now is equals to 6 all over cos 30 degrees is root 3 over 2. 3 all over 2 in short form. So you have R now to be equals to 6 times 2 all over root 3. So if you rationalize, you know this one is 12 already, 12 all over root 3, then times root 3 all over root 3. So this one will be 12 root 3 all over 3. So the final answer is 4 root 3 Newton. That is our resultant. Is 4 root 3 Newton. So we have to find F2. F2, you can say this is opposite over adjacent. That is tan. That is B part of the question. Tan 30 degree is opposite. Opposite is F2. Hypotenuse. Opposite over adjacent. Adjacent is 6. Multiply by 6. So F2 now will now be 6 tan 30 degrees. 6 times 30 degrees. So F2 now will now be 6 times 30 degrees is 1 over root 3 or root 3 over 3. If you multiply by this will be 2 root 3, then Newton. Case 4. Let's see case 4. When two forces are acting on a body at an angle theta to each other, where theta is 0 degree less than theta less 90 degree, meaning acute angle theta. So you have the diagram this way. You have F1 here, you have F2 here, then you have the angle to the theta. Then how do you find the resultant? So a parallelogram law of factor addition or addition, a parallelogram law of addition of vectors, is used. We are going to use parallelogram law of addition of vectors. So let's state it so that we can. This law states that when two forces or vectors, when two vectors are acting on a body at an angle theta each at an angle theta to each other, they can represented by the adjacent sides of parallelogram, by the adjacent sides of a parallelogram, in which, okay, by the adjacent side of a parallelogram, where you can add it, drawn to scale, comma, in which the diagonal of a parallelogram gives or represents the resultant force. Represent the resultant force. That's the law. This is theta. You form adjacent sides of a parallelogram. You can see this one is F1. This one is also F1. Opposite sides are equal. If this is F2 parallel, this is also F2 parallel and equal. So this is what you have. So you can use it to form a parallelogram. Then with the longer diagonal here, represents the resultant force. That's the rule. So after that, produce this down, join it here. That's straight form. You can see clearly if this is theta, this is also theta, alternate angle. That is alternate angle. And the sum of angle on a straight line is 180. This one has taken theta, so this one will be 180 degrees minus theta. Opposite angles of a parallelogram are equal. If this is 180 minus theta, this is also 180 degrees minus theta. This is how we managed to get this. So we can now bring out this diagram. Let's bring it out. This is the diagram. This is the diagram. This is the diagram. So this is the diagram. We have this one now to be 180 degrees minus theta. We have this one to be our F2, this one to be F1, and this one to be our resultant. Our resultant. So you can using cosine formula in mathematics. Cosine formula. When you use cosine formula, we are considering this particular angle. So we want to get R. It will be R squared is equals to F1 squared plus F2 squared minus 2F1 F2. Cos angle here is 180 degrees. 180 degrees minus theta. This we are using cosine formula. Cosine formula. So I can say, but in mathematics, cos 180 degrees minus theta is equals to minus cos theta. Minus cos theta. So anywhere you see that, you say R squared is equals to F1 squared plus F2 squared minus 2F1 F2 minus cos theta. So I want you to work this one out. The viewers at the comment section, if you are able to get it. If you don't get it, then I have to work it out again for you. If you don't know this, cos 180 degree minus theta is equals to minus cos theta. So this is what you have. So we say R squared is equals to F1 squared plus F2 squared plus 2F1 F2, that is cos theta. So our R now will now be square root of F1 squared plus F2 squared plus 2F1 F2 cos theta. This is the formula for finding the resultant when acting and tangle together. That's what you need to do. That's what you need to do. We always look for direction of the resultant. The direction of the resultant, this is alpha. That's the direction of the resultant. This is alpha. From the diagram here, if you produce this down, produce it, join it like that. Right angle triangle. This 180 minus theta, definitely this one will be theta. You know, it is only when this is theta, you take away theta from, you get this 180 minus, that is theta. So this place is theta. I can find from here to here, this is a adjacent over hypotenuse. You know, definitely from here to here will be F1 cos theta. F1 cos theta. This is adjacent from here to here all over hypotenuse. Don't forget F2 is from here to here. So we have gotten that. So let's see another one we want to get. We want to calculate from here. Let's calculate the height here. This is opposite over hypotenuse. So to be F1, remember this is F1. This is F1 sine theta. So let's calculate this. You know, this is opposite all over adjacent. So we can say tan. Question is direction of the resultant. Direction of the resultants. We are considering the whole of this triangle now. So this will be opposite, this will be adjacent, and we have tan, opposite and adjacent. So to be tan alpha is equals to opposite. What is opposite? F1 sine theta all over from here to here. That is F2 or F1 cos theta plus F2 or F2 plus F1 cos theta. So make alpha the result that is tan inverse of F1 sine theta all over F2 plus F1 cos theta. This formula is very important. That's the direction of the resultant.